I've got two options here. I could either look at it as the sixth root of 64 squared and try to find, we know 64 breaks up into 8 and 8s break up into 2s. So there's a group of 6. So the sixth root of 64 is 2. Raise that to the second power. That's how I get the answer. Or I could realize, hey, wait a second, 2 6 is the same as 1/3. So the third root of 64 is 4. I could start this as immediately doing the negative exponent flip it deal. But when we do that, that means the entire term, 4 to the 3/2, goes into a denominator. And then start dealing with 1 over square root of 4 raised to the third power, becoming 1 over 2 cubed. This is how we get 1/8. Or we could realize that this is the square root of 4 raised to the negative 3 power, being negative, or 2 to the negative 3 power. And now we deal with the negative exponent. Flip it. So 1 over 2 cubed. There again is the 1/8 answer. Parentheses. So 512 breaks up into 8 and 64. And every 8 breaks up into 2s. And wait a second, cubed root means you're looking for groups of 3. So we have one group of 2s, another group of 2s, another group of 2s. So if we don't memorize that the cubed root of 512 is 8, I could look at it as, well, this becomes 2 times 2 times 2 raised to the second power. Again, 8 squared. This is one reason why you get 64. Or if you do have your facts memorized, cubed root of 512 is 8 squared. We're looking at 64. So one of the things we need to memorize is that the fifth root of 32, or if you didn't, 32 breaks up into 8 and 4, which breaks up into 5 2s. So the fifth root of 32 is actually a solid integer, 2. And the fifth root of 243, we may not have remembered, but could have broken down into just a 3. We've got a group of 5 3s. So the ending answer is a 6. Now some of you multiplied the radicands, which is also correct, but then there's it was a perfect fifth root that ended up being a 6. So in order to get the x by itself, we're going to have to undo this power, taking the cubed root on both sides. Now we're seeing that the cubed root undoes that third power, leaving us with x minus 1 equal to a 3. Because it's an odd index, we do not have the plus or minus. This is how we get the answer x to be 4. You can also check your answer. 4 minus 1 is 3, and then cube it, it's 27. So in this one, we're going to divide by negative 5 first. After you divide both sides by negative 5, we get x to the 4th equaling 625. Now we're going to take the fourth root on both sides. This is where the fourth root undoes the fourth power. So x is equal to 625 actually breaks up into 125 and 5, and 125 is 5 cubed, and there's our group of 4. So fourth root of 625 is actually a perfect integer of 5. Wait a second, we have an even root? So that means this is going to be a plus or minus 5. If I check my answer, positive 5 to the fourth power is 625 times negative 5 gets us this. Negative 5 to the fourth power also gets us a positive 625, which times negative 5 also gets us to this. Plus or minus works. So in this problem, notice that the like terms are the same. They're both the fourth root of x. So we're just going to take negative 5 and add 2, getting negative 3 times the fourth root of x. The quickest thing to do here is multiply the radicands together, since we have a multiplication symbol in between the radicands instead of the last problem being an addition sign. We actually can find the product of the radicands. Combining we keep in mind that the exponents get added. So like we had a y in the previous radicand, y times y cubed becomes y to the fourth. Now we're looking for pairs because we have a 2 for the square root. So wait a second, 4 has a pair. Y to the fourth breaks up into 4 y's, so we have 2 pairs there. And then z also, if we break all of these z's up, we've got 2 pairs there. So the original 7, but then multiplied by a 2, y squared, z squared, and then see what's left on the inside. We've got an x and a z, so really the final answer is 14, y squared, z squared, times the square root of xz. So we're looking for the fourth root of 81. Or we can break this up and just zoom in on the fourth root of 81 times the fourth root of x to the 12th, all over the fourth root of y to the 8th power. And so anyway, fourth root of 81 is a perfect 3. If you break up all these x's and start circling your quadruplets, you would have 3 groups. Like, notice how you would divide that. 12 divided by 4. You'd have x cubed. And that stays in the numerator. Now we move to the denominator. If you have y to the 8th, and you need to break it up into groups of 4, you'd have 2 perfect groups, so it becomes y squared. This is our final answer. In this problem, we have a plus sign, so you cannot add the 2 radicands. You have to rationalize and then see if they're like terms. If they're like terms, we'll get them together, and if not, we leave it. So we're looking for groups of 3 within these radicands. 24 breaks up into 8 and 3, and 8 becomes 2 cubed. So we do have a group of 3 here. We do have a group of 3 within x to the 5th. So I can take out, all right, we have 4 times y. We had a group of 2's, and we'll have a group of x's, but then what's left on the inside? We're left with a 3x squared. On the other side, we only have one perfect group of 3, and that's the y. So we could say plus y times the third root of 3x squared. So are these like terms? We get 8xy times the third root of 3x squared plus y times the third root of 3x squared. Technically, like terms say you have to have the same exact variables, and this one has an x, this one doesn't. Ergo, this is an appropriate answer. I saw some students take it in a different route, but I'm not going to go through that. This is where I would stop. With compositions, what we're going to do is completely replace g of x and put it into f's function on this one. So we're going to all right, first step is realizing that g of x is the expression x squared. So instead of x now in f's function, we're now going to put x squared here. So this is going to look like negative 4, or sorry, no, not negative 4. 4 times x squared to the negative 1/2, which means you're taking 4 times, notice how the 4 is not in parentheses. So it's just x squared, or 2 times negative 1/2. When you multiply these powers, you get negative 1. So either we could stop here, or we could stop here. Those are synonymous answers. So my paper got cut off, but we are going to take f's function and completely replace it in this position for g of x. So realize that f's function is 4x to the negative 1/2, but g's function, so what it says in the directions, g of x is equal to x squared. So what we're going to do is completely erase the old x and put in 4x to the negative 1/2 in both spots. This time, 4x to the negative 1/2 has to be in parentheses. to the second power. So now the 4 is getting squared, and the x is being raised to both powers, meaning you multiply those powers. So I could either stop here, or if I wanted to take it one step further, it'd become this. Biggest mistake here is not distributing the minus sign. So the actual final answer was supposed to be negative 1x, or my bad, negative x squared minus x plus 1. And no, it does not factor. So in this one, f of x is x minus 3, and we're going to have to completely distribute that into g's function. I can't remember the function right now. Should have been plus 2x minus 4. If you completely distribute, you end up getting x cubed, and so on, getting like terms together. This was technically the complete product. So in this one, whenever you've got to find the inverse of an equation, we're going to change f of x to y, and then you start, okay, switch the x and the y. And then you have to start solving for y. So subtract 4 on each side. When you subtract 4, it goes away from that right side. And then you divide everything by negative 2. But we don't leave it with it being y equals. We use the notation for f inverse. So this becomes f inverse equals x minus 4 divided by negative 2. If you wanted to change that to where you took the x divided by negative 2 and so on, it could look like this. So these are the two options. I would have stopped there. So this one, we again set it equal to y, or change f of x to y, switch the domain and range, or switch the inputs and the outputs, switch the x and the y. Okay, add 3, take the cubed root on both sides. Because it's an odd index, we don't have to worry about plus or minus. But we don't stay with it being y equals. We go to the inverse writing. So it's got to be f inverse of x equaling the third root of x plus 3. This is the appropriate answer. So using the strategies we discussed yesterday, I'm going to move this function right 4 and down 1. It's a square root graph, so it's an arm. This original point started at 0, 0, but it's no longer at 0, 0. I'm going to move it right 4 and down 1. So now it's at 4, negative 1. The old point, 1, 1, is now at 5, 0. The old point, 4, 2, is now at 8, 1, if you want to go that far. And it looks like half an arm. This is what I was looking for. You could have either gone this route or actually showed me with the points of the old, and then how the inputs are affected inversely by adding 4, and the outputs are affected exactly as you see it. All of them subtract 1. So in this one, we're going to take the running man, where it looked sort of like this, with this turning point being 0, 0, and trying to figure out how does it move. And since this is inside the reticand, we're moving left 3, up 2. Or, those of you who are really good with the T-charts, you could go back to those original points and seeing how do they transfer. So the inputs are affected by subtracting 3, and the outputs are affected by adding 2, and then where does it go? So your new points, the old point 0, 0 is now left 3, up 2. The old point 1, 1 is now at negative 2, 3. The old point negative 1, negative 1, and so on. So the old point 8, 2 is now 5, 2. No. Whoops. Is now at 5, 4. That's what I was looking for. So when solving, we're going to get the radicand or the radical by itself. So we're going to subtract 2 to the other side. So 0 minus 2 becomes negative 2. then we need to divide by -1. So when we divide by -1, we get positive entities on both sides. To undo the fourth root, we're going to raise both sides to the fourth power, being able to cross those operations, cross out those operations, and we get x equal to 16. This, and then it checks out. 2 minus the fourth root of 16, which is 2, does equal 0. So most missed problem on the test, everybody, or most people got to this step, and then it went all haywire. Let's just rewrite it in the other form. Third root of x plus 8 raised to the second power equals 9. So let's talk about how do we undo what first. So because of the way I wrote it, I'm going to undo the square first. I'm going to take the square root on both sides, but now that I'm taking the square root on both sides, I'm going to insert a plus or minus. So this turns into, so wait a second, the square root undoes the square. So I'm left with this cubed root of x plus 8 still equals plus or minus 3. So now I'm going to raise both sides to the third power, getting me, oh, so the third root undoes the third power. So x plus 8 equals plus or minus 27. So I'm going to have to take -8 plus 27 and then subtract 27. We've got two possible answers here. We either get 19 or -35. And they both check out if I actually plugged those into my calculator or did it by head.